Good afternoon, FluxCon. I'm ecstatic to be here and supporting the first ever instance. Super stoked to be in the company of such luminaries who've done so much free, excellent work in open source, and we're all the positive benefactors thereof. Today I want to explore a very specific and powerful idea which we have adopted as a vision, which is why Control Plane is sponsoring the Flux CD project and the core maintainers, and that is Flux-powered GitOps is just a deployment mechanism, but fundamentally, that deployment mechanism can also be governance, compliance, and security, which is what we as a consultancy have been doing for the last 8 years, operationalizing that into secure software delivery. For those of you that don't know us, a quick introduction, and we'll go back through the journey of Flux. We are an 8-year-old bootstrapped cloud-native security consultancy, and we specialize in FSI, government, and regulated industries. We've been doing GitOps since 2018. I was tag security, co-chair, and personally led that security review to get to get Flux through its graduation process back in the day. We've written multiple white papers. Again, I wrote Hardening Git for GitOps for Weaveworks back in 2018. If we're going to use Git as a source of truth, what properties and security guarantees do we need from that system in order for our deployments to be secure? And it's self-evident things like branch protection, signing commits, making sure that there's 4 eyes on things, but still relevant to the new paradigm of deploying through GitOps. And then finally this year, we've bootstrapped FluxCon, as you can see in the Flux docu-series. And as Stefan was talking about, the operator is the big technical change to support complex deployment patterns without polluting the code base of Flux CD itself. So what are the problems we saw that we thought we could help to fix? Regulation rising, complexity of stacks and deployment models, teams stretched ever thinner, as we know. Governance and technical implementation then drift apart. On the one hand, the compliance team thinks the topology of a system looks one way. The reality is the operations team know it's very different, but we don't know where the gap in the middle is. When we perform threat modeling exercises for organizations, this is one of the first things we start off with. Can someone draw the architecture diagram of this system? We then allow the bun fight to ensue and go back and update Confluence. The result of all this is slow, fragmented delivery, misalignment between teams, inconsistent enforcement. That leads to operational fragility. Again, when we're working with organizations for whom downtime can be in the millions of dollars in very short time periods, these become extremely critical, not only to the organization, but in some cases more widely to a financial system. So how do we see Flux-powered GitOps addressing this? A vision of a control tower for governance. Good delivery is declarative, it is policy-driven, and it's auditable by default. These are guarantees we get from the append-only Merkle tree in Git. We want that same authoritative truth in 3 places at once, in Git, in the pipeline, and in the cluster. If it's approved in Git, the thing that actually runs it, then we have signatures, SBOMs. We're using Gitless GitOps for unified delivery mechanisms. We're not putting a Git production server in place anymore. We're using everything we know from OCI and all the good work that has gone into securing that. This gives us policy and traceable audits between environments. So the foundation of what we're talking about here is secure GitOps. We're relying upon the fact that Flux has been audited many times and not found wanting from a security perspective. There are clear end-user hardening guides. There are clear topologies for this is how you deploy a secure-ish Kubernetes. And here Flux is that hardened, trusted control plane to build everything else on top of and keep that audit record of what has been reconciled and deployed into production, by who, on which device, when did they come into the building. We can tie everything together with cryptographic chain of trust guarantees. This is a tamper-resistant foundation for everything else. Then we deliver secure platform services. Those are hardened, threat-modeled, secure by design, drop-in bricks that can be used to build whatever shape the castle is that we want to defend our infrastructure with. These hardened blueprints come in a curated set of service catalogs like service mesh, secrets management, ingress, those core extended control plane components that, in case of cluster availability questions, have to be running at the same level as the control plane, as etcd. These are critical to the deployment and uptime of the applications. These are pre-vetted, they're compliant, they're based on our experience with FSI and baselining it to every single framework under the sun, as well as the MITRE attack in various different forms. This gives internal teams a secure platform, pre-vetted, out of the box, not an assembly toolkit, although it can be decomposed and used to fit in however makes sense for your environment. And finally, we enable secure application delivery on top of that, building on top of those security guarantees at the lower layers, policy-driven continuous or progressive pipelines, SLO gates, change control, think P95 latency under 250 milliseconds, error rates at 0.2%, no critical vulnerabilities, CRA and compliance then come in from a different perspective, and crucially, cross-environment multi-cluster promotion, from dev to staging to prod. We've built in time windows, wave-based rollouts, automatic halting or rollback in the case of a gate being breached,